Welcome back to Brain Binge. You know, our story today, it doesn't start with a computer. It starts with a glitch, a fundamental weirdness woven right into the fabric of reality itself. Think of it like a ghost in the machine of the universe, one that we are only just now learning how to control. So let's dive into this strange new frontier together.
Yeah, that's a quote from Albert Einstein, the world's most famous scientist, right? And he was talking about this deep, profound mystery he stumbled upon in his own equations. A bizarre, almost magical connection between particles that it defied all common sense. He was convinced it had to be a mistake. But here's the thing. What if it wasn't? What if that spooky action was actually the key to a whole new kind of power?
All right, so to really get how we got here, we've got to rewind. Let's go all the way back to the very beginning, to the dawn of the quantum age. So, believe it or not, this whole thing kicked off back in 1900. A physicist named Max Planck was trying to figure out a really simple question. Why do hot things glow? And he came up with this wild idea that energy isn't smooth and continuous, but it comes in these tiny little packets he called quanta. I mean, this was a huge deal. It completely shattered the physics of the time. Then, just 5 years later, Einstein jumps in and builds on it, proving that light itself is made of these packets, which we now call photons. But, and this is the crazy part, decades later, in 1935, he co-authors a paper describing the very spooky effect that would basically haunt him for the rest of his life, quantum entanglement. And that mystery, that thing that bothered Einstein so much, well, today, it's the foundation for a massive global race. A race to build an entirely new kind of machine, one that doesn't operate on the logic you and I know, but on the strange, powerful, and kind of mind-bending rules of the quantum world.
Okay, so here's the absolute key difference. Everything you use, your phone, your laptop, it all runs on what we call bits. A bit is super simple. It's like a light switch. It's either on or it's off, a 1 or a 0. It's definite, right? But a quantum bit, or a qubit, well, that's a whole different animal. It's more like a spinning coin. While it's spinning, before it lands, is it heads or tails? It's kind of both, and that's a qubit. It's a 0 and a 1 at the exact same time. This crazy state is called superposition, and it's what blows the doors wide open for what's computationally possible.
And if you thought that was weird, hold on, because this is where it gets really strange. You can link two of these qubits together in a process called entanglement, and this is the spooky action that Einstein was so worried about. Get this, if you have two entangled qubits and you measure one of them, say you find out it's a 0, you will know instantly that its partner is a 1. It doesn't matter if that other qubit is in the next room or on the other side of the galaxy. That connection is instantaneous. It's this ghostly, faster-than-light link that gives quantum computers the potential to just tear through calculations that would take a normal computer, well, literally millions of years.
But we need to pump the brakes for a second. It's super important to remember that the quantum computers we have today, they're not the all-powerful code breakers you see in movies. Not yet, anyway. We're currently in what's called the NISQ era. That stands for Noisy Intermediate Scale Quantum. Think of these machines less like a finished product and more like experimental jet engines. They're incredibly powerful, but they are so fragile. The slightest little vibration, the tiniest change in temperature, what scientists call decoherence, can make the whole thing just collapse into a bunch of errors.
Okay, so these things are so unbelievably difficult to build. Who on earth is actually doing it? And how are they even pulling it off?
Well, that's the cool part. There isn't just one way to build a quantum computer. It's this frantic race between a bunch of totally different, incredible approaches. You've got the giants, like IBM and Google, using these tiny superconducting circuits that have to be chilled to temperatures colder than deep space. Then you have companies like IonQ and Quantinuum, who are literally trapping individual atoms in magnetic fields and poking them with lasers. It's wild. Meanwhile, places like PsiQuantum and Xanadu are trying to build these things out of pure light. And then there's D-Wave, which is taking a whole different route called quantum annealing, specifically for solving these massive optimization problems.
But here's what might be the most exciting part of all this. You don't need a billion-dollar lab and a team of physicists to actually use one of these things. Nope, companies, researchers, even students, they can access these incredibly exotic machines right through the cloud. Platforms from IBM, Amazon, and Microsoft basically let you rent time on a real quantum computer and run your own experiments from anywhere in the world with an internet connection.
So, okay, we can access them, but what are people actually doing with them? How are these experimental machines already starting to tackle some of the world's toughest problems? Let's take a look. In the cutthroat world of global finance, where every tiny fraction of a percent can mean billions, yeah, they're interested. Big banks like HSBC are already partnering with companies like IBM, using these early-stage quantum processors to try and find an edge, to build better, more complex trading models, and get a leg up on predicting how markets will behave. But maybe the most perfect, most natural job for a quantum computer is simulating nature itself. I mean, think about it. The world of molecules, of chemistry, it's all fundamentally quantum, down at its core. So these machines are just perfectly suited to help us design new life-saving drugs, create way more efficient batteries, and maybe even invent materials with properties we literally can't even imagine right now.
And this brings us to a really interesting paradox with quantum tech. On the one hand, as we'll see, it's a massive threat to all of our current digital security. But on the other hand, the very same quantum principles are being used to build the next generation of encryption, systems that are hopefully unbreakable, totally quantum safe, to protect our data in the future.
And we need that protection, because the stakes here could not possibly be higher. This isn't just some academic, scientific race anymore. Oh no, this is a geopolitical one. A quiet, high-tech shadow war, a new kind of arms race that could completely shift the global balance of power.
There's a phrase that keeps national security experts up at night. It's harvest now, decrypt later. And it's a chillingly simple strategy, with absolutely terrifying implications. Let me break down how it works. Step 1. An adversary, some other country maybe, secretly siphons up and records huge amounts of today's encrypted data. We're talking top-level government secrets, corporate R&D, maybe even your private messages. Right now, that data is safe. It's locked up tight, for now, but they don't try to open it. They just hold on to it. They wait, because step 2 is, years from now, they finally build a powerful, working quantum computer. And step 3, they use that future machine to crack today's now ancient encryption, unlocking an entire decade's worth of secrets all at the same time.
And look, the threat isn't just about breaking old codes. The military advantages quantum tech offers go way beyond that. We're talking about optimizing insanely complex military logistics, wargaming future conflicts with perfect information, creating truly unhackable communication channels for troops in the field, even navigating with pinpoint accuracy when GPS satellites get jammed or, worse, blown out of the sky.
So that glitch, that spooky little quirk in reality that so bothered Einstein, it's being turned into a tool with unbelievable potential. It could be used to design new medicines, to help us solve climate change, or it could be used to gain a truly insurmountable strategic advantage over everyone else. And all of this leads us to one final, absolutely critical question. In a world where information is absolute power, who is going to be the first to truly harness the ghost in the machine?
That's it for this episode of Brain Binge. If you enjoyed getting your mind twisted tonight, do me a favor, comment, like, and subscribe so you don't miss the next deep dive. Got a weird fact, mystery, or place you want an episode about? Drop it in the comments. I read as many as I can, and I'm always hunting for new ideas. Thanks for listening, and thanks for letting your brain binge with me for a while. Stay well, stay curious, and I'll see you in the next one.